So from this session onwards, we are going to discuss volume. So far we discussed surface area. Now we are going to discuss volume. First of all, before we move to the core sums of this chapter, let's discuss volume of the combination of solids first, right? We discussed surface area of the combination of solids. Now we are going to discuss about the volume of combination of solids. Then we are going to move for conversion, right? If we are converting one solid to another one, how volume is related, right? Then first term. So let's start with this question. A solid is in the shape of cone standing on a hemisphere with both their radii being equal to 1 centimeter. Okay, so on hemisphere there is a cone which is standing. That's what given over here. And radii, which is radius of hemisphere, and radius of cone is what? 1 centimeter. Good. So let's label that information. So here and here, that is 1 centimeter, both 1 centimeter. Good. And the height of the cone is equal to its radius. Okay, so height of the radius, this one, that is also 1 centimeter. Let's label that as well. So height, let's label from here to here, 1 centimeter. Okay, it will not match lengthwise, let it be, no worries. Find the value of the find the volume of the solid in terms of pi. So we need to find the volume for hemisphere and for cone in terms of pi. So we will keep pi as it is. We have discussed few sums where we kept pi as it is. Here it is already instructed that keep pi as it is. So let's start with the cone first. So cone it is. Let's start cone, C-O-N-E, simple. Now for cone we need to have radius, which is 1 centimeter, and it's given height is equal to the radius. So h is also 1 centimeter. Let's use the volume formula. So volume is what? 1/3 of pi r square h. It is 1/3 of this cylinder. Remember, 1/3 of the cylinder, 1/3 volume of cylinder. So let's substitute the value. 1/3. Will I substitute 22/7? No. See, in question it is given find in terms of pi. So keep pi as it is, into 1 square into 1, and let's simplify. It's very simple, 1/3 and pi only, right? So I can write pi by 3 centimeter cube. Remember, this is volume, so it will be centimeter cube, not the square, right? So we are done with the cone. Now let's move for the hemisphere. So hemisphere it is. Hemisphere. For hemisphere we only need radius, right? So radius is same, right? Is given radii equal radii. So 1 centimeter. Now we need to find the volume. So let's use the formula for volume. Now hemisphere, that is half of sphere. So half, and what is the volume formula for sphere? That is 4/3 pi r cube. Done. So 1s and 2s. So 2/3 into pi into 1 cube. So it is 2 pi by 3 centimeter cube. Then so volume of cone, volume of hemisphere. Now let's add, because this is a combination of solids, right? There are two solids, cone and the hemisphere. Now let's get the volume of the solid. So volume of the solid. What are we going to do? Are we going to add or subtract? Simple, we are going to add it, because when we join those two shapes, we are going to get this combined shape, which is given here, pi by 3, okay, and another volume is what? 2 pi by 3. So pi plus 2 pi by 3, which is 3 pi by 3, 3 get cancelled, so pi centimeter cube. This is the volume of this arrangement, right? You must be thinking that volume is pi only, right? This happened because we have taken radius and the radius and height of the cone as 1 only, and radius of the hemisphere also 1. So because of that we are getting this kind of irrational number. No worries. So steps are going to remain same as for the surface area. You find the volume of cone, volume of hemisphere, you add them and you get the volume of this arrangement.